Hello and welcome. Today, we're going to be detectives. And what's our mission? To finally crack the code on that document that shows up every single month but can feel like a total mystery, your electricity bill. We're going to take it from just a page of confusing numbers and turn it into a story you can actually read, and, maybe more importantly, a story you can control.
You know that feeling, right? You open up the bill, your eyes kind of glaze over all the charts and the jargon, and you just scan right down to that one final number at the bottom. But what does it actually stand for? What are you really paying for every time you flick on a light or plug in your phone?
So let's put a number on it. For our little investigation today, our mystery number is exactly $50. This is our case file. And I promise, by the end of this, you'll know exactly how all the activity in your home adds up to this number, piece by piece.
Okay, so to solve our $50 mystery, we first have to learn the language. We need to understand what the electricity bill is actually saying. And the key term, the secret code word that unlocks the whole thing, is the kilowatt hour.
See, what you're paying for isn't just electricity in some vague sense. You are paying for electrical energy. Just think of it like this. It's the total amount of energy that gets transferred to an appliance over a period of time. It's not a momentary zap of power. It's that sustained flow of energy that actually does the work, like heating your water or lighting up a room.
And how do we figure out that total flow? Well, it's with this really simple but incredibly powerful formula. Energy equals power multiplied by time. Honestly, this is the heart of it all. It's really just a two-part story. How much power an appliance needs, that's the power part, and for how long you leave it on, and that's the time part. If you change either one of those, you change your bill. It's that direct.
And that brings us right back to the star of our show, the kilowatt hour, or kWh for short. This is the unit, the little package of energy that your electric company sells to you. And the definition makes it so much easier to picture. Imagine you have a 1,000-watt heater. If you run that thing for 1 full hour, you have just used 1 kilowatt hour of energy. That is the product you're actually buying from them.
And what's really interesting here is the sense of scale you get. You know, in science class, the standard unit for energy is the joule. But just look at that conversion. 1 single kilowatt hour is the same as 3.6 million joules. Can you even imagine getting a bill that says your usage is in the billions or trillions of joules? The numbers would be meaningless. So the kilowatt hour just makes everything way more manageable for us regular people.
And just to complete the picture, let's do a super quick refresher on the power part of our main equation. Now, power itself can be calculated using these classic formulas from physics, depending on if you know the voltage, the current, or the resistance. You don't really need these to read your bill, but it's cool to know that this is the science that's humming away inside every single device you plug into the wall. All right, enough theory. Now it's time for the good part, connecting these ideas to actual cash. In this section, we're going to take everything we know about watts and hours and turn it directly into dollars and cents. This is where we solve the case. So let's open our first case file, that 1,000-watt heater. Let's say you run it for 3 hours on a cold morning. It's a really simple two-step process. First, we've got to convert the watts into kilowatts. So 1,000 watts is just 1 kilowatt. Easy enough. Second, we multiply that by the time. So 1 kilowatt times 3 hours equals 3 kilowatt hours. That's it. That's the total energy it used. So you figured out your total kilowatt hours. Now what? Well, the final step is incredibly simple. Your total cost is just the amount of energy you used, which we measure in kilowatt hours, multiplied by the price your utility company charges for each one of those units. That is the whole game, right there.
And now let's go back and close our original case. Remember that $50 bill? Okay, so let's imagine that over a whole month, all of your appliances, the lights, the fridge, your TV, everything added up to a grand total of 250 kilowatt hours. Now, if your electricity rate is, say, 20 cents per kilowatt hour, you just multiply those two numbers together, and there it is, $50. Mystery solved, case closed.
Okay, so you've seen how the pros do it. Now it's your turn. We're about to make you the official energy detective in your own home. Let's run through a few quick cases here just to test out your new skills.
All right, here we go. Case number 1. A 200-watt TV runs for 5 hours. How much energy is that in kilowatt hours? Case number 2. Your fridge uses 2 kilowatt hours every single day. How much energy does it use in a 30-day month? And the final case. If your electricity costs 15 cents per kilowatt hour, what's the bill going to be for using 120 kilowatt hours? Go ahead, take a moment, do the math.
All right, let's check the results.
For that TV, the answer is 1 kilowatt hour. The refrigerator, over 30 days, actually uses a pretty hefty 60 kilowatt hours. And that 120 kilowatt hours of usage, that's going to cost you exactly $18. See? Once you know the formulas, you're the one in control.
But, just understanding the math is only half the battle. The real goal here is to use that knowledge to actually take control. So let's look at the master plan for managing your energy use, and of course, your monthly bill.
And it really doesn't have to be complicated. Here are 4 super simple strategies that tie directly back to our formula. First, switch to LED bulbs. They use way less power for the same amount of light. Second, turn off lights and devices when you're not using them. That directly reduces the time they're running. Third, when you buy new stuff, look for energy-efficient appliances. Again, that's attacking the power side of the equation. And finally, unplug those vampire devices that suck power even when they're turned off. That's a sneaky way to cut down the time you devices are using energy. Every one of these actions directly lowers your final kilowatt-hour number.
So, there you have it. The code has been cracked. You now have the tools to look at your electricity bill not as just some demand for money, but as a summary of your actions. It's the story of your home's energy use. Which leaves us with one last really important question to think about. Now that you know how it all works, which appliance in your home is the biggest energy user? That's your next case to